Thank you, Chandra. Hello, everybody, and welcome to our webinar. First of all, it's such an honor to be standing next here to Andriy talking about this. So it's super cool for me and for MindsDB and for everyone to be able to listen to this webinar. So let's definitely have to start over there. So I'm going to go through some slides. I'm going to do a bit of the boring part of this webinar, but really what I really want is for everybody to understand and know what does MindsDB do and how is this relevant for AI applications, and also give a quick intro into knowledge bases, which is like what we are all here about. So I'm going to share my screen and somebody can give me a quick thumbs up if you can see it. I think people, awesome. All right. So what's MindCB, right? And MindCB, what we're talking about is really our mantra here is how do we bring AI closer to your data, closer to enterprise data? And we do this through our framework called Connect, Unify, and Respond. So I want to have everyone to keep a good reminder of like these three words because they're going to come up a lot in the next few slides. All right. And who's MindCB? Well, all right, we're one of the most widely adopted AI query engines in the world. We have already 400,000 deployments on our open source that I hope that everyone's going to go jump in and add some numbers into this. We have over 30,000 GitHub stars, and we're really lucky to have all the community to be able to go in and use MindsDB to solve their AI problems. We also are backed by some of the biggest industry leading tech partners such as Google, NVIDIA, Snowflake. You can see the logos. I don't need to read them. But also backed by top investors such as NVIDIA, Benchmark, Mayfield, and Y Combinator. And so really what I want to be able to this slide talks about it's not really just about like, all right, who we are, like how big we are, but like why is this that we made it this far? And I think it just has to do a lot with like how we're connecting data, how we're bringing the federated query engine that I'm going to talk about in a second, but really that zero ETL support for large scale enterprise customer data. I think that that's the biggest thing that we have to keep in mind here. So really, what do we do, right? When we think about AI implementations, there's a lot of things that we need to talk about, right? Like we have enterprise data or customer data. You have to have ETL extraction tools. You have to transform this data. Then you have to have AI reasoning, planning, data orchestration. How do you bring all this data to the bottom layer, those AI agents and apps? And that's what really MindCB is really good for, right? Like we simplify all the process to make it sure that we're just using MindCB. You can access your enterprise data. You can ask questions about it. You can see like what do I need to answer from a structure, unstructured data, but also how do I generate a federated query engine that just makes it easy to access data regardless of where it lives. So Minds, as I'm telling you, right, the main point here of MindCB is like, how do we connect this data into AI agents and the apps? And that's where like the MindCB power comes in. We have our knowledge base that we're going to talk about a lot today. We also have cognition, right? Like the ability to understand what the queries are, to what the questions, where the data lives, and also how do we learn from the actual user's actions and the data to be able to make it better and more efficient as also as the system continues to grow on and that perspective. But the main idea is, all right, I want to bring this data. How do I query it? How do I bring that closer to AI? How do I make sure that I can answer the right question? So our tech stack has these three main components, right? The connect piece and the connect side, which is based on our federated query engine, which we translate just normal SQL to any query language that's required on the underlying data structure. So it doesn't matter if your data is in Snowflake or if your data is in Postgres or in MySQL, you can use SQL and it automatically will transform into that. So that makes it easier for you to make queries to bring that data closer to that perspective. Then we have the unify section, right, which is all about knowledge bases. And it's like, how do we make sense? How do we make that data easily accessible for AI to be able to understand it? So we're going to talk a lot about knowledge bases today, but that means a lot of embeddings perspective. That means like, how do I do parametric searches? How do I make semantic meaning searches? So we have to be able to unify that data so it can actually be really readily accessible by AI and make it to be able to respond the right question, which comes into the last section, right? The cognitive side of things, the respond, the actual what's the question and what's the response part. So this kind of includes like all the planning, all the reasoning. Like if I have a question about customers, like where does that data lives? So you have to be able to integrate vertically fully from where your data lives into your AI application in order for you to be able to work like in a really cool way for your AI application to work. So now let's get really to what we're here for. So we've been developing knowledge bases for a little bit over a year at this point, and I want to really kind of highlight what are the main features of knowledge bases and the way we think about this. The first way is really we're making MindDB is a very SQL driven uh, piece of software, right? So how can we really make the most out of it by using the simple and already known SQL commands, but also to leverage knowledge bases. So we're going to see it in a second, right? But we're going to use create statements, insert statements, select statements. And we're using normal SQL, we can actually create and search and look inside all the different applications inside our knowledge bases. So it makes it really easy for people to like just jump in and start using knowledge bases in a second. It also, of course, like it allows you to do intelligent searching by using embeddings and semantic meaning, but we also included a re-ranking process so that now we can also make sure that your search experiments are actually relevant to the user query. So all those kind of things comes included, and we like to think about this. So another way to say this, we like to think about our knowledge bases, our batteries included. They already have everything that we need to make sure that you have a really good performance and optimization. We are very flexible in terms of model and storage integrations. We connect to the major LLM providers like OpenAI, Azure, Bedrock, among others, and we can keep on adding new connection and new model sources pretty much every single week. And also you can select different type of vector databases that will help you in your different like type of deployment where you're going to do. We kind of do favor PG Vector as the one that we are the most compatible and most of our features will work perfectly there. But the really cool thing is like when you think about SQL, right, it really allows you to do a lot of like algebra, a lot of different things to make sure that that you can actually perform the right queries to get the right data what you need. So we're trying to bring that logic also to knowledge bases. And if we apply that to different metadata filters, and different things that we can have in a knowledge bases, it can really help you going deeper into the actual data that you want to be able to find using knowledge bases. So we're going to see a lot about this today, but definitely encourage everyone to really test out uh, our algebra capabilities on the different types of filtering that we can do whenever you're going to search inside a knowledge base via the different queries. And lastly, we do this is I think the biggest statement for that batteries included statement. Once you insert or create a knowledge base, we do all the complex stuff for you, right? We do the chunking, we do the embeddings, we do the updates. The whole thing is just ready for you to be able to go in and really don't have to worry about like how do I create the right chunking strategy? How do I create the right embedding strategy? Like, do I need to change this? Do I need to update fields? Everything is already batteries included, so it's make it really easy for users to maintain, update, or keep a knowledge base up to date. And lastly, for those who already done rack systems and knowledge bases, evaluation is quite a key and complex part of it. And the main thing is, how do I make sure that my knowledge base is actually performing in the way that I want? And so we also include evaluation systems that you can just go in, create your knowledge base. It will create some sample questions and answer pairs, and you can start really looking, hey, is my knowledge base actually bringing the answers when I actually doing for? So we really help developers get to the right point in terms of like checking the right level of performance for your knowledge base. All right, really quick, I'm almost done. So just want to show about like what we're talking about the SQL capabilities of the knowledge base. So this is the syntax to be able to create a knowledge base inside of MindDB open source. What you're going to be able to see is just a simple create knowledge base command. And then inside using, we start selecting what are the type of models that we want to be able to do, what are the storage that we're going to be able to use for like when we want to store a knowledge base. You can have this MPG vector, select another table, and also like what's going to be the metadata columns, the content columns, and the ID column that you're eventually going to be able to use whenever you're actually doing the more specific use cases of knowledge bases. All of these parameters are optional, but it really kind of helps you simplify that with just this simple create knowledge base command. You create a knowledge base, and that's all you need to do. And in the same sense of spirit, and just this last example, querying a knowledge base. Querying a knowledge base is also an easy SQL statement where you can just select ID, or you can select star, or select content, or remember the type of values that you want to bring back. And you select your from the knowledge base name that you just created, and you go in here in the content. This is going to be your query. And you can even start like this is where you start using metadata filters, like only show me results that have a high level of relevance, or show me where metadata filters is equal to red or blue or a product name. So it really helps you to be able to get to that perspective. All right, so those are some of the two quick examples. Please, to be able to go for this, we have our docs section under MindsDB documentation, where we have like all of this documented and all the different things that you can do with knowledge bases. With that, I'm gonna stop this boring part of the presentation and get to the good stuff with Andriy. But before we do that, uh, I have a poll that you're gonna see in your screen. Basically, just want to help us to get read of like what's your level of familiarity with MindsDB. Have you trusted before? Are you familiar? Are you new? We can see that a lot of people are just getting new, so I kind of feel like this wasn't too bad of an initial boring presentation. I'm glad that everybody get to know. Please do share your questions, and we have a big community to also jump in and be a part of that we are able to go in and answer more in details. So with that being said, Andriy, up to you.
Thanks, Alejandro. Okay, let me, so just to explain what it will look like. So I will walk you through through the process of creating a knowledge base and showing how to use it to answer factual questions about your data. I prepared a notebook, so we will really look into different cells, and I will explain to you what each command or function does, so that at the end of this walkthrough, you have a clear idea of how to reproduce this in your specific business setting. So please put your questions in the chat if you have something you would like to clarify. Alejandro will keep an eye on this question. So if he sees that some question would better be answered right away, he will interrupt me and I will answer. Or if it can wait till the very end, then we will continue. We will continue the tutorial and then we will answer it. So I will share my screen here. Okay. So yeah. So what is a knowledge base? Because well, we need a definition of the term to be sure that we are on the same page. So the definition of the knowledge base in MindsDB context is a special view of your table. So imagine a table with documents that you have in your business setting. For example, those messages are emails, or so this table contains email messages from users or reviews of your goods in an online store, or interactions with your partners, anything, some documentation, and so on. So you would like to be able to ask natural language questions to this table, and if the table contains a document that answers your question, then you would like the system to tell you, okay, based on all these documents that you have, the question to your the answer to your question, for example, what is the product that my clients are the most excited about is this. So it can combine multiple messages where clients are excited, and answer you as a textual answer in the chatbot like interface. For example, saying that this client said that they were excited about this product because XYZ. So you want an answer not based on some general knowledge of a language model, but really grounded to your data. So this is what we call a knowledge base. So it's a special view of your data where you can communicate with it using text and the system on the background will use some semantic similarity between your questions and the actual documents, and only bring you the answer based on this semantically similar documents. So, well, to start working with MindsDB, we need to install dependencies. So here we will install all dependencies needed for this specific tutorial. So we install MindsDB and SDK. SDK it's a developer API that lets developers interact with MindsDB programmatically, and specifically here we will use Python SDK. So we will need pandas. For those who don't know, it's a structured data manipulation library. We will need it to just prepare the data, because, well, for this tutorial, we didn't use an actual corporate database. So we decided to show how it's done based on the IMDb movie descriptions. So to manipulate a data set with movie descriptions, we will use pandas. Well, request is to connect to the external sources with the data. Data sets, it's where it's Hugging Face package to interact with the data on the Hugging Face model and data hub. And this is for the spinner. When we will wait for the insertion, just the spinner will entertain us in the process. Okay, so first of all, we need to get the data with which we want to work. So as I said, it will be IMDb movies dataset. So to download the dataset, we use the datasets API from Hugging Face, and specifically the function load dataset. So we will use pandas to. Once we downloaded the dataset, we put it into a pandas data frame. We will only use the train split just for the sake of simplicity. So we don't train anything, but the train split is the largest of the two splits that come with the from the Hugging Face. So normally Hugging Face is for training model. So every data set is split into two or sometimes three pieces, like train, validation, test. So the train is the largest one. And we will print it to see what exactly we downloaded from Hugging Face. So I will run this cell. It should be quite fast. So it started to download. Okay. So what do we see here? We have 1, 2, 3, 4, 5 columns. So we have a movie title and year. We have a genre. We have expanded list of subgenres. We have a rating, and you see some of them are not defined. We will need to address this. And we have a short description of this movie. So what we will do, we will clean the data, and we will also make sure that every record in our dataset has a unique ID column, because when we will create a knowledge base, it will be tied to, so the knowledge base ID of some element will be tied to the original table from where this element was taken to put it into the knowledge base. So we need those IDs to be unique. So first of all, we will rename the tables, the columns, just for the sake of simplicity to work with. So movie title dash year, we will call it movie underscore ID. Expanded genres, we will just replace dash with an underscore, and the description will become content. And also, we will clean the ID. As you see here, it's a combination of movie name, dash, and the year. And sometimes those movie names contain some special characters and some really weird characters that might interfere with how the data engine treats the ID. So we will only keep in these IDs characters that are normal characters. So we'll remove quotes, question marks, asterisks, and so on. So it will just remain a nice looking clean ID. And so we will apply this function to each movie ID. And we will also drop duplicates. So as you know, many movies, well, many years may have the same movie produced by several different companies across the world. So sometimes there are two movies shot in the same year that have the same title. So just to avoid duplicates, we will drop them. But in reality, like when you work with your business data, I don't advise to drop duplicates. You would rather define a fake ID that would be incremental. And in this case, even if two movies share the same year and title, they will have two different numerical IDs. But for us, it's better to drop because we want to reduce the size of the dataset with which we work for the sake of this webinar, because if we work with hundreds of thousands or millions of records, we will wait for significant time to until the knowledge base is created. So after we do all this, we save this data frame, pandas data frame, into a CSV file, and we will work with this CSV file going forward. So as you see, we started with 238,000 original elements in the dataset. And after removing all duplicates, we ended up with 161,000 records, so 161 unique movies. So all of them are now in this CSV file. And we again show the data frame. We see that all is good. And now our columns have new names. Yeah, and the ratings are good. So yeah, and the rating, you see, we filled the column we filled the missing values for rating with 0. This is one of the standard practices to deal with missing values when you do data analysis. Okay, so now we have our clean CSV. So what we will do, we will load this CSV into a table. And this is where your actual, corporate part starts, because normally you already have this table somewhere in your corporate warehouse or the database, but we will load this CSV into a table, and MindsDB will be then used on it. But before we do it, we will connect to MindsDB. So basically, I use this URL. It's a URL that you get when you start a Docker container with MindsDB on your local machine. So I use my laptop. So when you go to the documentation section of MindsDB, there is a specific section that explains to you how to run a kind of a standard Docker container in your environment, and it comes with everything installed. And when this Docker container starts, it makes available this local URL with which your SDK will communicate to make changes in the MindsDB database programmatically. So here we connect, so we import this SDK and we connect to our running MindsDB instance. And we just to see that we successfully connected, we will also list all the databases that are already installed in the container. And we see that there is files and there is this database. I will explain to you what it is later, but it's from my previous experiments. So it's a vector store that contains vector representations of different documents for the similarity search. But for now, ignore this. If you run this tutorial from scratch, this one will not be there. And files is just a special database that is used when you upload files on MindsDB. So all files that you will upload and store as a table, they will go into this files database. So now we created, so we connected to our MindsDB instance. And what we will do next is that we will upload our CSV file to MindsDB. So we will use Pandas read CSV API. We will get the database, this files database, which is available. So we will connect to it. And it's important here. As I said, like when you want to upload a file to MindsDB, you must use this files database. You cannot upload into any existing database. And we will create a table, call it movies, and this is where our file records will go. And in the end, we will do a couple of selects to see if everything went well. So I will once again run this cell. So here, for the sake of consistency, we drop a table if it exists. So there was already a table movies again from my previous experiments. So we dropped it, and then we created a new table movies. And we executed these two selects. So to execute any query in MindsDB, when you use a Python API, so you use the notion of server. So you connect to the MindsDB server, and then you use this server object, and it provides the query function where you can put your select, like your regular SQL that you would usually use to select the data from a table. So you actually write select movie ID, genre, rating from. Here you put your table, and we put limit of 5. And this is what we see here. Okay. So our select here, we used the parameter rating higher than 7.5 for two reasons. The first reason is because we don't like poor quality movies, so we will work with good quality movies. So usually on IMDb, if a movie has a rating above 6.5, it's watchable. But if it's above 7.5, it's close to something eternal. So we will concentrate on these really good quality movies. But the real reason is that, again, I wanted to reduce the size of the data set we will work with because it's tutorial, and we wanted to be reasonably quick. So after we filtered out all movies that have ratings below 7.5, we end up with 10,152 movies. And when we look at them, well, no, this is not from the last query. This is from the first query. So this still shows ratings below 7.5, but this is after we filtered out low rating movies. Okay, so now we are close to creating the actual knowledge base. So now we have a table in our database. In the database, with the name of files and with the table name of movies inside this database. So now we want to create a knowledge base based on this database. So what we will do? Well, again, we will drop any knowledge base with this name if it already existed. And this is the query, so the SQL command that creates a knowledge base. So as you see, it follows a very typical create table structure, but with uh, some using parameters that are specific to knowledge bases. So first of all, when we create a knowledge base, we need to provide an embedding model. Why it's needed is because we will do retrieval augmented generation, or RAG. So for those who are not familiar with what RAG is, RAG is a concept that that can be used to answer some questions based on a collection of documents. So it works like this. So the user submits an input. An input is it might be a question, like, for example, which product some users like, okay? And this query is being encoded. Encoded in the sense that it is converted from a textual representation into a numerical representation that we can then work with to find semantic similarities. So basically, this encoding happens by applying some pre-trained neural network, such as, for example, a language model or a bird like an encoder. So think of it as a model that was trained on a lot of documents, and now this model can expose its internal representation of these models as in form of vectors. And once your input query is converted into such vector, we need to find documents that are similar to this this vector. So for this, we also apply encoder to all documents in our collection. And then when a user submits some new input, it's getting transformed into this vector, and then there is a part that we call vector search. It's very similar to finding a cosine similarity between two documents. So the vectors representing documents and the vector representing the input, they are all compared one by one. And the comparison is applying cosine similarity, so to finding a cosine between a pair of vectors. And then we will only keep the documents which had a high enough cosine similarity with the vector representing the input. So once we reduced our entire pool of documents to just the maybe, I don't know, 15 to 20, sometimes 5 to 10, depending on the application, then we take all these documents, we submit them into an LLM, and we say, okay, based on these 10 documents and the user query, what is the answer? And do these 10 documents contain this answer? If yes, answer the question. If not, return something like impossible to answer, or something like this. So this is RAG. So to implement this with MindsDB, you don't need to create this entire pipeline. So it's all created for you by the MindsDB engine. So here we provide the embedding model from OpenAI, which is quite powerful. We also say that the columns that we want to use as metadata, which means that you can use them in the select command when you work with the knowledge base. So you can use genre, expanded genres, and rating in your where clause in select. So you can say, find me movies that talk about something, where genre is mystery and rating is above 8, something like this. And the content column, it's important. The content column will be the column that will contain the user query. So this is where you will say, content equal to, and you put your actual query you want to ask to your collection. And the ID column is movie ID, as I explained. So this ID column will contain the same value as the original database. So now we are ready to create the knowledge base. So we run this query. So here for now nothing happens. So the knowledge base is created, but it's empty. So there is nothing really to wait for. So we just receive the output that says that knowledge base was created, and this is where we input our data or inject our data in the knowledge base. So again, it's a very similar command for those who are familiar with SQL. It's insert into select. So you say insert into my knowledge base and select, and this is here you provide the fields from your original table with the movie with movies. And you specify again, well, you want rating higher than 7.5, but this is redundant. We already did it earlier. So this is where we will have to wait a little bit, maybe a minute or so. So this is why I created this nice spinning snake. I don't know, snake. So we will wait for it to finish. So what happens right now is that the data from the movies table is copied to the knowledge base. In real applications, you will, if you have millions of records, of course, you will not sit and wait like this. There is a special commands in this insert into knowledge base syntax where you can say, I want to use a batched insertion, and you can define the size of a batch. In this case, so currently, well, you say, okay, it's finished, but I will finish to explain. So when you use batched insertion, you will need it's asynchronous. So you will not wait anything. It will say right away, okay, but the data will be inserted gradually on the background. So if you don't use batches, it's synchronous, and you wait until it finishes. So this is why we needed something smaller for this presentation. So now the data is inserted correctly. We can check what's inside our knowledge base. We see it contains 10,152 rows. So it's exactly the same number of rows that we had in the original table. So this is good. And now we can actually execute queries to our knowledge base and see what it gives as an answer. So what we will do, we will define a search underscore knowledge KB function that will take a query. Here it also can take a limit. So this is the number of documents we will send to the LLM. So I defined it as like a default value of 5, but if you want, let's say, to see up to 100 customer appreciations for some of your specific product, then you will have to increase this limit so that you show to an LLM more than 100 documents to choose from. Current LLMs support very large contexts. For example, Claude from Anthropic supports up to 200,000 tokens. Gemini from Google 2.5 Pro supports up to 1 million tokens. So you can really, fill the context with a lot of documents that were retrieved in this phase. So you shouldn't feel like you're limited to 5. You can be limited to hundreds or thousands, depending on the size of your document and the size of the context that the model accepts. So like a typical way to communicate with the knowledge base is through select. Okay, so you use select. You can just specify asterisk, or you can specify fields that you want to see in the output from your knowledge base where content equal to. So contact is, as I said, it is a special column in the knowledge base that accepts your query, and your query can be anything. So it can be any text you feel fits in your business setting. And for those meta parameters that we specified, for example, we can also specify that genre is equal to, and we can provide the genre here, and we can provide rating equal to. So if we don't provide anything of this, only limit will be used and the query. And the limit goes here, like again, similarly to any SQL select. So you can define order by, and you can define limit here. So now I prepared a couple of questions based on my test. So like my first question that I want to ask to my knowledge base is, what Anakin was lured into by Chancellor Palpatine? Okay. And I will run this query and we will see what happens. So first of all, you see, yeah, no, sorry, it was my last question. No, my first question is, who a boy must defend his home against on Christmas Eve? Okay, so you can probably guess who is this, but we ask it to our knowledge base. And the answer we get, the boy must defend his home against a pair of burglars on Christmas Eve. Why the answer was given like this? So this comes from your knowledge base. Why? Because in our query, okay, we called the knowledge base with this. And the knowledge base returns what we call chunks, relevant chunks. So if your documents are large, then before they are embedded into embedding vectors for RAG, they can be chunked into smaller pieces. And those each individual pieces are embedded into vectors, and then the embedding of the user question is compared not to the entire documents, but to each chunk in the documents separately. In our, again, example of IMDb documents, they are small enough, so they are not chunked, but still, like every document has one chunk, basically. So here we see the table that was returned by the knowledge base for this query. And here the limit is 100, so we have 100 movies returned by the knowledge base. And you see the Home Alone movie is second, okay? But because we send to our LLM more than one chunk, then it receives this and this and this and this and this. And then we ask our LLM to, this is how it happens here. So there is a prompt here. I don't know if you see it well. Yeah. So you're a helpful assistant that answers questions about movies using only the provided context. Of course, you can work on this prompt. You can make it a little bit more instructive. But overall, the model receive the content from this chunk, and then answers the user question based on this content. So the model is quite intelligent to figure out that it's about this movie that the question is asked. But Alejandro talked in the beginning about the reranking possibility, and when you create a knowledge base, you can also add a reranking model, and this reranking model will reorder this table based on how LLM thinks these chunks are relevant to the query. And after reranking, there are very high chances that Home Alone will be the first one. But it's it improves the quality of RAG, but it's not a deal breaker for our specific case, because our questions are quite simple, and any modern LLM is capable of figuring out which one of these 5 chunks is relevant to our question. But if you want, you can provide the reranking model, and the reranking model will take this table and it will calculate a different similarity score based on its understanding of text. And you can replace order by relevance with order by reranking relevance if you want. Yeah, and finally, the second question that we will ask, what Anakin was lured into by Chancellor Palpatine. So we run it, and here you see we have like three Star Wars movies at the top, and we send these chunks to our LLM, and our LLM says that Anakin was lured by Chancellor Palpatine into a sinister plot to rule the galaxy. Yeah, so this comes directly from the movie description. So this is it. I think you now understand how simple it is. That SQL is your main interaction language with the knowledge base, but we use Python as glue around the different SQL commands, because SQL is good for one-shot interactions, but here we have a process. So when you have a process, you need to combine multiple interactions in one chain, and using Python as a glue is a natural choice. So I will stop here. I will pass the mic to Alejandro, and we will see if we have questions.
Thanks, Andriy. This was really cool. Really appreciate the full effort. And I think it was a couple of things we are really noticing was like really the use of metadata filters to being able to filter by genres to filter by relevance. So like really helps you narrow down your search results from like that 10,000 movie results pool into just a few ones. And if you're able to narrow down the pool, usually knowledge bases results also get better. Also noticing, right? Like you probably noticed with like that snake when Andrew was inserting all the movies into the knowledge base. We inserted 10,000 rows, and that was like 10,000 calls to an embedding model, and we kind of did it in less than a minute. So also, I think it's very we've been focused a lot on making it super efficient and super fast. So that when you actually do this, because somebody has done embeddings in the past, it kind of takes away way longer from that perspective. Um, so we do have some cool questions from the audience. Um, that we have just some house cleaning ones. And will the user get a copy of the document of this
Of
notebook?
this notebook, yeah, sure. I can brush it a little bit so that it looks presentable, and we can attach it to the post.
Amazing. All right. So another question coming in live. What kind of chunking from Vivek Navyar? What kind of chunking is happening in the background? Considering if it's converting to file to markdown, are the chunks by section? So how we do chunking on MindsDB, we do a default chunking size of 1,000 tokens, and we also keep an overlap of around 200 tokens. So that's for the default piece. But once you go into the deeper configuration of MindsDB, you can set up your chunking size to the number that the user will do. What I really like to think about this is that whenever you're like deploying a full-on production knowledge base, you want to be able to query, in the end, you're kind of searching for like optimal optimizations, right? And marginal gains to be able to make your knowledge base perform better. And sometimes you have to test with different models. Sometimes you have to test with different chunking sizes and see if actually some of that things will actually make an improvement in your overall results. So we make that easy in terms of our knowledge base to be able to change all these features, to create different samples of different knowledge bases using different models and stuff like that that will help you then that once you create it, then you can use to evaluate models to like really start looking if like you're getting improvements on your performance. The second part of the question was like if you use the file to markdown. So in terms of the knowledge base, one of the cool things is like how do you actually insert also unstructured data into a knowledge base? So we provide tools to bring on PDFs or even like information from web crawlers that will able to extract that data and put it in a table format that then it's ingested into MindsDB. So you can also make sense of the unstructured data and then start asking questions around it. Um, all right, I think I had another one here that I want to answer. Yes. So another question from Nilesh Bawiskar. Sorry if I am murdering your name. Apologies. Anyways, What if a database has been updated with some new entries? Is it needed to update knowledge base or it gets auto updated? So the knowledge base does not get automatically updated. It's in our roadmap, so eventually you'll see that coming in soon. But we have a function called jobs that you can automate to start inserting data automatically into your knowledge base. So for example, if you're tracking a specific table, you can set a job that whenever a new index is created on that table, that it automatically inserts it into a knowledge base. So it's not automatic, but it's semi-automatic once you're able to create those jobs to keep on inserting data into your knowledge base. An interesting question just coming right on the chat from Maria Pan. You're doing embeddings and where you stored embedding vector points. Are you using any specific vector bases? So I think this question relates to like which vector stores you can use to store your embeddings. So MindsDB, also another question that came through the QA was we're not a vector store, right? Like MindsDB is not a vector store. Like there's other things that are happening also over there. But the main thing really is that you can select a different vector store to use your current to store your knowledge base. By default, if you don't select any, MindsDB will create a ChromaDB vector store inside of MindsDB where you can like leverage and use your knowledge bases. But we really do encourage users to use Postgres with pgvector, right? Not only because of their open source, because like most of the capabilities and functions that we build towards knowledge bases are targeted to work on that specific vector store. But if not, you can also there's like third-party options that you can use to store your vectors in that perspective through different data handlers. Um, I think I had another question here marked live. Can the filters be, this question from K and M, can the filters be automatically created via the query? So I think the interesting part there, like if you're using the Python SDK, then I think you can manipulate the query in different ways and formats, similar to what Andriy is doing here, where he was selecting genres or where he's selecting different type of things. You can definitely automate it via the MindCB SDK, and you can modify the query on that perspective. So I really like this question because it really kind of triggers the creativity of the users and the people using this platform. Is like, all right, if I have this really cool capability to filter around using different type of metadata, labels, relevance thresholds. How do I make it incredibly dynamic? And I think you're on the right path, right? Like if you use Python, you can probably build this, you can build the select query uh, programmatically, and then eventually you'll get the results of what you're searching for. So that's pretty cool. I love that the direction that's going. Another question coming from Ashok Narayan. What embedding model was used? The embedding model, I believe so, Andrew, that you used
Yeah, it was
OpenAI,
OpenAI large
OpenAI
embedding
large,
model.
right? Right. Yeah, a little bit right on the a bit above.
Mhm. Well,
There you
yeah,
go.
yeah.
Exactly. When you create a knowledge base, you specify the provider. So in this case, it's OpenAI, but you can use like Azure OpenAI. We also support Google, and we also support some custom LLMs and open source via Light LLM. So you can select like different type of models. And what I like about this is like and I think I kind of echoes on the previous answer that I made. We want to be able to make sure that the meant to be knowledge bases are really flexible, that users can select different type of models that can go for one that they're familiar, one that they like, they want to try the new state of the art. And just by changing the different like model names and the providers, that's exactly how you're able to get this. Of course, you're going to need your API keys on all that good stuff, but we want to make sure that we are able to be very flexible at that perspective. Oh, an interesting question from Cyprian just coming right live on the front. You mentioned hybrid search in the presentation, which I think I meant semantic search with metadata filtering. Usually, hybrid search means combining lexical with semantic search. Is it possible to do this within MindCB? Yeah, so you get like great question. Hybrid search at this point, what we have implemented in MindCB is exactly what you mean. We have semantic search with metadata filtering. We are implementing our hybrid search capabilities, which I think it's really interesting when you go into knowledge bases. Is like, how do I make sure, like, if I have a keyword, to give it an additional weight or point? So we're building a hybrid search functionality. Keep your eyes on them. It's on a roadmap. That's actually going to come out really soon. So if you're really looking forward to use hybrid search, we would love to get you on board on that one and get your feedback. And I think we're almost at time, Chandra. So I know you're going to want to. I'm going to leave a couple of moments for you to say something, if that's pretty much it.
Well, yeah, I would just like to add that this is very straightforward as an approach because, well, I wasn't familiar with MindsDB that much before I joined MindsDB as an advisor. So it's been probably about a month that I started to work with it, and the documentation is very clear. A lot there is a lot of it, and it's very user friendly. There is now this copy documentation button, so you can copy it and paste into an LLM of your choice and ask questions about the documentation, which is really cool. And I really like this sticking to the SQL paradigm about everything. So for someone who has a lot of experience with the databases, I think it's very simple to switch into using this very modern, AI applications. And the fact that you can use Python SDK to connect all of it again is very dear to my heart. And yeah, and also what is cool is that today many of us we don't code anymore. We use what they call vibe coding. So basically, you say an LLM what you want, and it gives it to you. And uh, those LLMs are effective in such kind of requests when they were trained on a lot of data about what you are asking about. And what is good for MindsDB is that it has been there since 2016 or 19, you said, Alejandro. So like it's been more than 6 years, let's say, and the documentation and the entire GitHub and the user questions about MindsDB, they are all in the index of major LLMs today. So when you ask questions about MindsDB, there are very high chances that your question will be answered well. This is a huge advantage for any company who has been there before ChatGPT because it has been indexed well. So if you create today a company, a tech company, and people start asking questions about it, LLMs will be of no help. So I recommend you to try it yourself, and you will see how easy it is to create this kind of pipeline.
Amazing. Thank you so much, Ande. Also, thank you so much, Alejandro. And then lastly, thank you to everyone who joined our call. Feel free to join our community. The link is in the chat, as well as check out our documentation. I have also linked that for you to check out. Ande, it has been such a pleasure for you to do this demo. And once again, thank you everyone for joining. Have yourself a lovely, lovely day. Bye, everyone.
Thank you.
Thanks,
Bye.
everybody. Appreciate it.